All right, hello. Hello, morning. Hello. So I'm back from COVID, and today I'll be talking about the Codebase. So just before we start, has anyone actually gone through every single file or looked through their Codebase? Okay. Has anyone explored other repos on the Coders for Causes GitHub and had a look at the Codebase? Yeah? Okay, so today mainly we'll be talking about just basically the structure of a Codebase. I think it's good to understand how a Codebase is structured, because then you just know where to find things, or at least where things go wrong, or when you want to change things, you know where to change them. So yes, generally we have a front end, which has our components, pages, assets, utilities, tests, backend, models, routing, views, utilities, and tests as well. This might be different depending on the framework that you use, or even the team that you're working with. Apart from this, we also have other folders like Docker, GitHub workflows, environmental variables, and for some repos, we do have a documentation folder as well. So yes, most code bases follow almost the same structure. It's just very helpful just to understand this. You don't really have to know what each file does, like how it works. The important thing I would say is just to know what the job of that file does, or what is actually being stored. So yes, the more structure there is, the easier it is to maintain. It's also easier to work with others. So this is why it's important to follow conventions that you have to agree on with your team. So yes, so front end, we have components, pages, views, routes, assets, utilities, and tests. So to start off, we have components. So what components are they're just small parts of our UI. So it could be a nav bar, modal, things like that. Things that are, the reason why we have components is because we don't want to keep rewriting code. We want to be able to reuse things. So doing it this way just sort of adds a layer of so you can reuse things. And then next we have pages and views. These are very similar. Well, with pages are direct components that are related to a specific route. So depending on the framework that you use, again, in React you could have pages, and in Vue you would have views. And then next we have public, or the assets folder. So these are normally where you store your images, your logos, so generally things that are just referenced to by the front end. And then testing. So this is, it's in the name, test scripts are just added here. Sometimes you want to add tests in other folders. This is where you add the .spec extension to the file. And yes, I think we'll be doing Cypress testing in our projects. Cypress is just a framework that is used for front-end testing. So yes, comparing code bases with other code bases, it is, like I said before, it will be different depending on the tech used, or the tech stack that's used, and the team that builds it. This is why it is important at the start of the project to agree upon certain conventions that the team will want to use for the project. And this could even, not only does this apply to the file structure, it could be also file naming conventions, or commit messages, things like that. It just makes it a lot easier to deal with when there is some structure, and I feel that it's more, when you actually do it properly, it's more satisfying when you actually see that progress is done, because everything is really neat and easy to maintain or find. Okay, next we have the backend code. So we have backend's basically has a subject-oriented file structure. It could have a role-oriented file structure as well. So backend, normally they have a models file, routing, views, utilities, and tests. Again, this depends on the framework that you use. So here's an example of a backend folder from the Waste project last year. We have our different apps, like all defined here, and these are our settings. So yes, what subject-oriented file structure means is that folders have same file names based on the roles, and files can become folders as well as the application grows. We'll expand on this down the track. So yes, role-oriented file structure. So different folders have file names based on its subjects, like this. And then models. This is just a quick recap of what we did last week in the Django workshop. So this is where your ORMs are defined. So you use your ORM and you use models. Your models are defined to interact with the database instead of writing SQL into your code. So this is more backend stuff. Next we have our views. These are just sort of, views are the methods that are called when your API, or the methods that you use to interact with the database. URLs, where your API URLs are defined. A lot of this is like, yeah. And then testing. So yes. And I'll go through the other examples about Docker and stuff like that in the examples. Just right ways. So for example, in our waste folder, like I said before, we have our client, which has, if you go into SRC, where the source code is, we can find our components, layouts, routers, views. So like I said before, depending on the framework, this could be either pages or views. So these are just where like you have your different pages that link to the different URLs. So like we have a 404 page here, the page where like we show athlete management, history page, things like that. And within these pages, we make use of our components. So normally we would import these components in, so we could reuse them, like this here, like nav bars, modals, and errors. This is just, again, so we don't have to keep repeating ourselves. And then we might also have something called layout. So like, the way you can think of layout would be like how each page is a nav bar and maybe like a side nav. See, these things are common across most pages. Like for example, YouTube, like you have the top bit is always constant, and the side bit where like your subscribers, your subscriptions are, it's always going to be there. This is like a use case of layouts. Assets, this is where we have our logos, where they're just referenced. Okay, moving on. Okay, we also have routers. So this is just where, our page routes are defined. And service. So service is sort of where you can define things that do works for you, like sort of, if you wanna, like an all service, like signing in, signing out, maybe even like a notification thing, like if you want to trigger, basically all your services are here. And then last week you have testing, so end to end. Okay, there's no end to end here. Okay, moving on. Oops. Next we have okay, let's go into the Docker. So Docker folder is where our Docker containers are defined, where we build the Docker images. I wouldn't have to worry too much about this because this folder does not really change much unless you're changing the development environment. So Docker files is just sort of where your Docker images are defined. And then if you do see a script file here, what this file is basically is it just gets read in by this Docker file and gets run when the container starts up, if you understand Docker. Then next we would have, oh yes, one more thing. For the client, we also do have files like package.json and yarnlog. These are basically our package manager files. Very important. So in your package.json, you can actually, it lists all your dependencies. You can even define scripts here. So this would be an important place to, just know that the scripts are here for your project. You can define all your scripts here. And interesting thing is you can actually use package.json to define a script that fires up Docker to do your testing and things like that. So like here we have, it's just making it easier, like shortcuts for you when dealing with your project. And then depending on if you use yarn or npm, you'd have a log file. So this is just sort of the file that it just tells npm or yarn that for a certain dependency, it has to have a certain version or above this version, so you don't run into dependency issues. Okay, next we have our backend code. Yep, so we have our main API, our different apps like before. Our models where the database models are defined, URLs, database views. Another interesting thing is, so Python's version of npm or yarn would be poetry. Pip is not very good because it doesn't actually have a file where it stores the versions of the dependencies that are being used. And from experience, it is a big pain if you do pick up an old repo and you try and install stuff from using pip or dealing with dependency issues. So that's where poetry comes into play. And yes, poetry.lock is similar to the log file above, where it just defines look at the versions that are allowed. These three files here are all related to poetry. Okay, next we have our env files. Okay, so in this case, env is just a template, but normally we don't want to leave things like URLs or passwords into our code. So this is just where it's just an external file where we can keep these secrets. And we don't want, another reason why we leave it in an env file is because we don't want to commit this to our Git repo. And then we have our other Docker files here, like our Docker compose file. All this does here is it starts up our Docker containers like all in one command. Because like in the case of this, in the case of this repo, we have, let's see, we have 1, 2, 3, 4, 5 containers that start up, and it's a pain to start Docker, these containers one by one, and like connecting all the ports to each other. So this is what Docker Compose helps us with. And of course we have our README for our repo. And lastly, for this project, we have our .github folder. So this is sort of where our GitHub related files can be defined. So has anyone heard of GitHub Actions? GitHub Actions. So where you can define your automated testing, automated deployment, and things like that. Like just basically automatic jobs. So like you can set, this is where like jobs like, see for example here, Python linting. So on each pull request, open, synchronize, reopen, edited, it'll run this job, and it'll just basically set up a whole like system in the cloud, and like run these commands here. So like install Flake8 and run Flake8, and basically you can configure it so that if this test fails, you can't actually do your PR. Oh wait, I've got the other ones. Okay, next on to Elucidate. The tech stack for Elucidate is very similar to Waze. So like before, we have our client, Docker. Docker is pretty much the same as Waze, where we have our Docker file runtime, and things like that. Yeah, actually, it is very, very similar to Waze because we are using almost the same tech stack. Yeah. Actually, it is the same tech stack. Yep. Yeah. And then so I wouldn't worry too much about these, but it is a good idea to look into even if you are like front-end team or back-end team, I would suggest just having it like play with the code on the other side or the whole repo, like try and understand what each file does, because that's what I found was really helpful when I first started. And then on to poops. So yeah, so like I said, like you don't really have to know how each file works. You just need to know like what they do. So like for example, eslint.js, we know that all the linter configs and stuff are defined here, right? Or prettier. Just this here, this is a testing framework. And then we have our basic package.json, tailwind configs. So a lot of them, the file names, they're pretty self-explanatory. VS Code, these are just like settings that pop up when you open VS Code. Another thing that you might see is, actually no, yeah. That's it for the introduction to code-based structures. Thank you.